Good morning, students. Myself, RB Suksare, Department Machine Tool Technology. Here, in this chapter, in this unit, the revision classes, that is Introduction to Machine Tool Design. In your question bank, explain machine tool design. What is meant by machine tool design? The design of new machine tool can be justified in individual cases on the basis of productivity and accuracy, lower metal requirements of machine tools, etc. In general, all these ideas, which accounts for the cost of manufacture of machine tool and its operation, can be unified into a general index of economic effectiveness. A machine tool is a machine which converts raw material into the required shape and size, dimensions, and accuracy. The unwanted materials are removed from the raw materials in the form of chips, that is machine tool design. Next question, write the classification of machine tools. Here the classification of machine tools are according to direction of major axis, that is horizontal center lathe, horizontal boring machine, etc. Vertical lathe, vertical axis milling machine, etc. Inclined, that is spatial, example transfer machines. Next one, according to purpose of use, general purpose, that is central lathes, milling machines, drilling machines, etc. Next one, single purpose, example facing lathe, roll turning lathe, etc. Next one, special purpose for mass production. Next one, according to degree of automation, non-automatic, that is centralized lathes, drilling machine, etc. Semi-automatic, that is capstan lathe, turret lathe, hobby machines, etc. Automatic, example single spindle automatic lathe, Swiss type automatic lathe, and CNC milling machine, etc. According to size, heavy duty, example heavy duty lathes, example less than equal to 55 kilowatt boring mills, planing machine, horizontal boring machine, etc. Next one, medium duty, example lathes 3 to 11 kilowatt, column drilling machines, milling machine, etc. Small duty, example tabletop lathes, drilling machines, milling machines. Next one, micro duty, example micro drilling machine, etc. That is the classification of lathes, machine tools. Next question, list the general requirements of machine tool design. The list of general requirements of machine tool is, it is high productivity, ability to provide the general accuracy, shape and size, and also necessary surface finish. Next one, simplicity of design. Next one, safety and convenience of control. Next one, good appearance. Next one, low cost of manufacturing and operations. That is the general requirements of machine tools. Next question, write block diagram of the engineering design process in respect of machine tools. Here the engineering design process applied to machine tool is the requirements, what you need, requirements. Second one, precise definition of requirements after modification and expansion. Definition you want. Next one, precise definition of the requirements. Next one, technical specification. To idea about technical specifications. Next one, development of proper kinematic solution and selection of proper layout. Next one, design calculation for various unit of machine tools. Next one, design of components and parts and assembly drawing, technical specifications. Next one, prototype fabrication and testing. And here the requirements up to selection of proper layout, that is design proposal, and requirements up to various units of machine tool, that is preliminary design, and requirements up to prototype fabrication testing is detailed design, that is the engineering design process. Here the diagram shows that the engineering process applied to machine tool. This process is carried out 3 steps, that is design proposal, second one preliminary design, and third one detailed design. That is requirements. What your customer requirements? The customer outlines the requirements by furnishing information about the parts for the machine of which he want machine tool to be designed. The information should include the manufacturing of parts and their annual outputs, the dimensions and shape of surfaces to be machined, material of parts, machining tolerances, and the quantity of surface finish required. Sometimes the customer may have lack of specialist knowledge or may often not be in a position to define his need exactly. The assign must first of all check that the requirements of a new design in genuine and suitable product does not already exist. The designer must there make a preliminary assignment of the requirement to see whether it is economically feasible, and it is necessary that he may have a consultation with the customer to modify or expand the requirement to increase the market potential of the design. Next one, selection of proper kinematic solution and layout. After technical specification have been laid down, the designers explores the combination of relative motion that can ensure machining of surfaces of required shape and dimensions. The different possibilities are evaluated, and those found technically feasible are selected kinematic solution. on the basis of basic motion and combination are now developed. All these solutions are analyzed for this technical feasibility and is in feasible solutions are screwed the kinematic solution correlates the motion of workpiece and cutting tool can be realized in a member of layout of major machine tool units. Next one, design calculation. Design calculation concerns the design of major unit of the machine tool such as the need for speed for feed box, brake spindle, etc. These calculations are done in accordance with the design procedure only for these versions that are found must suitable on the basis of proceeding analysis. The final version are subjected by company where the economic feasibility of implementation of alternative by comparing. Next one, drawing of components and assembly, sub-assembly. Drawing are made for the version that finally selected. The drawing must be complete with dimensions, tolerances, and manufacturing specifications, including the manufacturer to be employed. Special care should be taken during the shape of design calculation and detailed drawing to make the use of standard components and assemblies as far as possible. The feedback that is obtained after prototype fabrication and testing and particularly analyzed to make appropriate change in technical specification and subsequent design. In design process itself, the designer should adopt a flexible attitude and is prepared for make modification in technical specification and even requirements. That is the design process of engineering design process of respect of machine tool. Next one, sketch with neat sketch. Explain with neat sketch shank design of single point cutting tool. Here the shank design of single point cutting tool is cutting force, three direction of cutting force px, py and pz and width and height. The shank of single point cutting tool may be rectangular or square or half round. Most common use square section withstand T formation due to compound bending stress. It is used for bearing and threading. The half round section tool is used for internal thread cutting and boring. The tool is designed from the point of view of strength and rigidity, assuming that the tool is loaded as a cantilever beam. The tool forces acting at the cutting edge is as shown in figure. All the forces except the force PZ is neglected for design. Here, therefore, the actual bending moment produced by the force PZ is moment of bending moment is equal to PZ into L, and permissible bending moment is induced internal is given by permissible bending moment M dash B is equal to stress into Z, where stress is permissible bending stress of the tool. Z is the section modulus of the tool material. Z is BH square by 6 is the rectangular cross section formula used. Z is equal to 5 dq by 32 is circular cross section used, and Z is equal to BQ by 6 is the square cross section is used. In order to make design shape, MB dash is greater than equal to MB, that is MB dash is equal to MB. Substitute the value of equation 3, that is stress into Z is equal to PZ into L. Stress into Z is equal to PZ into L. BH square by 6 because it is a rectangular, stress is equal to PZ into L divided by stress. Sigma is right side. That is BH square is equal to 6 into PZ into L divided by stress. B into bracket 1.6 B square is equal to 6 into PZ into 3.2 into B divided by stress. That is B into 2.56 B square is equal to 13.2 into PZ into B divided by stress. B cancel. That is 2.56 B square is equal to 19.2 into P2 divided by stress. That is B is equal to square root of 19 into PZ divided by 2.56 into stress. The deflection of the cutting tool can be obtained from the following equation, that is delta is equal to PZ into L cube divided by 3 into EI, where E is a Young's modulus of the tool material, I is a moment of inertia, that is I is equal to BH cube by 12, that is rectangular cross section, I is equal to B raised to 4 by 12 square cross section, I is to D raised to 4 divided by 64 is a circular cross section. The value of deflection must be within permissible limit, which is around 0.005 to 0.012 mm. First problem. A 10-degree backrake angle of single point cutting tool is used for machining on a lathe at speed of 60 meter per minute. The dia of the workpiece is 100 mm. Find the cross section of a rectangular tool shank. Assume a rectangular shank with height to width ratio is 1.6b and tool overhanging is 3.2 times the width. The recorded value of the cutting force is 2500 Newton. Assume Young's modulus E is equal to 2.1 into 10 to 5 and shear stress is 75 Newton per mm square. The given data is speed V 60 meter per minute, diameter 100 mm, height 1.6 b, length is 3.2 b, Young's modulus 2.1 into 10 to 5, PZ is 2500, stress is 75 Newton per mm square. You find the B, H and delta. Natural frequency Fn is equal to 0.625 divided by square root of delta. Fc is equal to 1000 into V divided by pi into D into 60. B is equal to square root of 19 in 19.2 into Pz divided by 2.56 into stress. That is answer is 15.81 mm. H is equal to 1.6 means 1.6 into 15 is equal to 25.99. L is equal to 3 into 2b, that is 3.2 into 3.2 into b, 3.2 into 15.81 is equal to 50.59 mm. Deflection delta is equal to Pz into L cube divided by 3 into E into I. That is deflection is equal to 2000, stress force is 2500 into I is 50.59 whole cube divided by 3 into 2.1 into 10 to 5 into 21310.6. That is delta is equal to 0.024 mm. Natural frequency is equal to 0.625 divided by square root of delta. 0.625 divided by square root of delta is 0.024, that is the 4.03 cycle per second natural frequency. And cutting frequency is 1000 into V divided by pi into D into 60. 1000 into 60 divided by pi into D is 100 into 60 is equal to 3.18 cycle per second. That is natural frequency is always greater than cutting frequency, so design is safe. Next question. A single point cutting tool is used for machining on a lathe at a speed of 70 meter per minute. The diameter of workpiece is 130 mm. Find the cross section of a circular tool shank. Assume the overhanging length of tool is 2 times the diameter of the tool. Recommended value of the cutting force is 2500 Newton per mm square. Assume 2 into 10 to 5 Newton per mm square. Permissive stress is 18 Newton per mm square. End of the national frequency as well as cutting frequency is equal to V is equal to 70 meter per minute. Given data. Diameter 130, length is 2D, Pz is 2500, stress is 18 Newton per mm square. Here, defining the diameter of the cutting tool is m dash V is equal to mb. Z is equal to Pz into L divided by stress. Here the 5d cube divided with it because it is circular, d cancel and 82 into 2 divided by stress d cancel. That d square is equal to 64 into Pz divided by pi into stress. That is d is equal to square root of 64 into Pz divided by pi into 80. Its answer is d is equal to 25.23 mm. L is equal to 2D is equal to 2 into 25.23 is equal to 50.46. Finding the deflection delta is equal to Pz into L cube divided by 3i. Pz is 2500 into L cube is 50.46 divided by 3 into E is 2.2 into 10 raised to 5 into 198.90. That is I is equal to 5d d raised to 4 divided by 64. That is answer is 19890.18 mm raised to 4. Finding natural frequency 0.625 divided by square root of 0.02 m, that is 4.03 cycle per revolution. Cutting frequency is 1000 into 70 divided by pi into diameter is 130 into 60 is a stress, that is 2.8 cycle per revolution. You always natural frequency greater than cutting frequency. Thank you. It is a first chapter unit revision class. Thank you one and all.